Hey guys, welcome to Code Decode. In this video, we are going to implement Mapstruct from scratch in a Spring Boot application. In an enterprise level application, we never work with entities only. For an example, if we have a full stack application with a front end and a back end, the data which is transferred from front end to back end and back and forth between both of them will always be the data transfer objects, that is DTOs, and the object that is saved in the table with the backend logic implemented will always be in the form of entities. Thus, we have two different beans, the DTOs and the entities. And we should never use entities to transfer the data between layers of backend, be it controller to service to repository, or between frontend to backend. We should always use data transfer objects or DTOs to transfer data from frontend to backend and between different layers of backend, that is controller, service and repositories. And only use entity to save the data in database. To implement this scenario, we must need some mapping between this DTO to entity. Now for an example, if we have a form in the front end, we might not save all the fields in the front end form to backend, or we might save some extra fields in backend based upon some business logic written in the backend. So the fields in DTOs and entities might differ. Now how will you map these entities and DTOs with each other? The answer is Mapstruct. What you would have done if Mapstruct would not have been there? You would have used populators or mappers and manually written some getters and setters. Rather than doing manual work so much with Spring Boot to add getters and setters for DTOs and entities, we would rather use Mapstruct, which is also internally getters and setters only, but it is generated automatically by Spring Boot for you, thereby reducing your manual work, and the chances of human error is also less using these automated mappers given by Spring Boot to you. When you implement Mapstruct, these populators or mappers where you get from one bean you set into another bean, or you get from DTO to and set in entity, or get from entity and set into DTO, these mappings and setters and getters will be automatically generated by Spring Boot in the target folder on Maven install and Maven up. So remember, whenever you implement Mapstruct, do not forget to do Maven clean install and update to generate these mappers in the target folder. So let's get started and implement the Mapstruct from scratch in a Spring Boot project. We are going to use Spring Initializer to create a Spring Boot project now.
Hey guys, recently we have launched a course covering an end-to-end full stack application using Angular as front end and microservices and Spring Boot as the back end. Also, we have used Cloud to deploy this application, and we have used CICD, that is Jenkins and Argo CD, for continuous integration and continuous deployment. The technologies that we have used is RESTful web services, Spring Boot and microservices for backend, Angular for front end. GitHub we have used for version control system. Also, to make the code unit testable, we have used JUnits. We have used Sonar for code quality checks. Also, for containerization, we have used Docker and Kubernetes. And to deploy this whole application, we have used AWS and multiple services from AWS. Also, we have used SQL as well as NoSQL, that is MongoDB and SQL. On AWS, since for the SQL we have RDS, we have used those services, and Jenkins and Argo CD for CI/CD pipeline. Also, this is an architecture of the application that we have created where the front end is Angular and the back end is microservices. We have used ALB load balancers, Ingress for routing and load balancing. And we have used SQL and MongoDB for SQL and NoSQL DB management with Eureka server and all those microservices counterparts. Now, this is the CI/CD pipeline. This is the CI/CD flowchart for the application that we have created on local. So this is something, a flow when you create an application in local, push it to GitHub, create a Jenkins pipeline and do the CI/CD using Jenkins and Argo CD. And at the end, deploy the whole code at AWS EKS. Complete description of this course is covered in a very separate video. The link for that video is also given in the description bar below, and also the link to purchase that course from Udemy is also in the description bar below. So please go and check the description for all these links.
Please do like, share and subscribe to support us so that this video reaches to more of the people preparing for interviews like you.
So this is Spring Boot validation mapper demo. So this is going to be our package name, and this is the demo project for the Spring Boot application. Now let's quickly go for next. Okay, just a second, let me make it 8 for you. And I'm good to go. Now here we will be adding some dependencies. Now for your reference, I have created this document and have added this at readme.md here. So here if you can see, in the GitHub, you can see all of these steps added here. Even I am going to follow this. We are going to quickly use these steps and create it. You will have this with you so that you can implement it in your own project. So what all we need? We need a web dependency, Spring Web dependency. What next we need? We need a Lombok, because I don't want to write getters and setters. I am a lazy developer. Then what else we need? We need MySQL connector, because I am going to make you connect with the Hibernate and JPA. Then we have data JPA that we need. So we have Spring, okay, not data. Do we have something for JPA? Spring data JPA, great. So these are already added. We need Spring's data JPA, starter web, connector and Lombok. Great, we are good. Remember, this is not the final form. We are going to add few more dependencies, but this is the minimum form that you need to make it up and running. Now, the first thing we need a console. I need here. And the next thing I need is, with the preferences, I need to make my console have a greater performance. Great. I also need to see my progress. Great. Okay. So we are here. The pom.xml is ready. So we are good with the pom.xml. We have added all the dependencies that we needed to get started. Now, the next important thing that we need to do is to configure the database. So we have this particular JPA with us. We have the MySQL connector. Now the last thing that we need to do is to connect to the database. So the first thing that I'll do is I'll open my DBWare. Now I'm showing this also here, but I got so many comments how to open this. So it's simple. Just go to marketplace, help, go to marketplace, search for this DBWare, and you will be able to have this DBWare in your perspective. That's it. Nothing more, nothing less. If that is done, I'll create a connection again. So this is going to be password. Test the connection, connected, and I'll finish. Great. So there was already a local host. I have my database here. These are all my databases I have. Now I need to create one database explicitly for this project for you guys. So I'll create a new database and I will name it as SB Validator. Don't use such names in real-time projects. They will give you left and right. I'm just using it for the demo purpose. So our database is ready. I'll copy the name here and I need to configure this database in my properties. So now this is the very important point. Spring has many things created for you in default. Now Spring Boot, you will see that how will I override these default properties, right? So application.property is the place in Spring Boot where you can override the existing properties for Spring Boot, for Spring. So here whatever I write is going to override. So if I write server.port, so if I write server.port, so can you see this automatically popping up for me? So the server.port is the default value is 8080. I want to run it at 8081. So in Spring Boot, this is how you can do that. Override the existing properties with Spring Boot application.properties. That's how I have made sure that my Tomcat, which is added here with my Spring Web and with my plugins, with this particular thing, I have added this has embedded Tomcat. So this embedded Tomcat runs on 8080. So with this overriding, it will run on 808. This is how you override. Now, next thing is how to connect it to with this database and how to make sure that you are able to create tables here. So if you can see here, I don't have any table. So there is no table here. So that is why it's empty. Now when I create my entities, the table should be automatically created, and that is the Hibernate for you guys, which will convert your POJOs or object-oriented classes to your tables that is persistable in the database or the hard disk in your system. So that's the conversion that is done by JP and Hibernate for you guys. Now we need few properties, and these are the properties. I'll make sure you understand all of them, don't worry. So we have Spring data source. So data source is the database actually. The source of your data becomes your database. So that's the URL. This is going to be my database name. So what is my database name? I'll try to copy if it is going to allow me. No. So let's try SB. If you type this wrong, your system will not be able to connect with the database. So make sure this particular name matches this particular database name. Next is going to be your password and username, which I was trying to hide from you, but now it's open. So what I will always suggest is that once we'll be covering the security, you should have this in encrypted format. So we will see in upcoming sessions how we can encrypt this password and not to put such critical things as the string in the properties file. The next thing is I need a SQL driver to connect to the system. So this is how you put the SQL driver in the Spring properties. Next are the three very important part. That is for JPA. These are JPA specific things, okay? Now I want that whenever a query is fired, it should be shown on console. This is also an interview question many a times asked in this way, that how can you make sure that whenever you fire a SQL query, it should be shown in the console. The way to do that is using this particular property. So by default it is false. That means even if you do fire a SQL query, it will not be visible on console, and you will be wondering what happened, how this data got added to the system. So to better make sure that you make this true, so that you can see those in console. Next, the auto DDL auto. So in Hibernate, we have four things. Okay, I have this PPT ready. So in the Hibernate property, we have four things: the create, update, create dog, validations, and none. Now what this property do? If you make it create, so what will happen every time I run this particular application, it will drop all your tables, which is the worst thing you can ever do. But that is what the create will do. And all your data will be lost, everything will be lost. And then again a complete new schema, just the structure will be created with the empty data into it. So never try to use create. If you do that, all your data will be lost. Make sure you don't use it. Now what I always prefer to use is update. So what update will do is, it will check whether the existing schema is present. If it is present, it will compare it. So schema is nothing but a row and columns together. That is schema. So schema is nothing but a collection of rows and columns. So in case after some time, my team lead comes to me and says add one more column. So I don't have to drop everything in my table, drop all the rows. Don't do that. Rather just make it to update. As soon as you add a variable to the table, that is to entity, it will be automatically added to your schema. I'll show that to you in few seconds. Similarly, create drop, it will create and drop the database after all operations are completed. This is only for unit testing. You don't have to do it. Testers will do that when they just want to test it at a particular, like in AWS, your instances are very heavy and they are very costly. So if you use the database that frequently and keep the database connection open, you will be charged and you will be have lots of force on your pocket. So not to do that, you can use create drop when you are testing on an instance on Azure or AWS, where you have to just test your functionality and just drop everything up. So that's where it is used. We are going to use update, so that whenever in future I need something to be updated in my schema, just I'll add that column to my entity and that will be reflected as a column in the table also. So that is why I always prefer update. Now the next, the database platform, I'm going to use MySQL 5 InnoDB delete. That is the delete for connecting your application to basically the Hibernate or the SQL. So this is the interface. You can consider it as your Java application, your table, This is your table. Oh, currently we don't have table, sorry. One place you have the application, one place you have the table. The connection between those is done by this database platform, InnoDB Dialect. If that much is clear, I'll quickly move to creating the, just a second, I'll move to my Spring. Okay. Now I'll quickly move to create our application, and just to make sure that things are all right up and running, I'll just try to run it once so that we don't cry after creating all our controller service and everything. I just want to see if the things are updating. So great, we have started our application. Great, things are all fine with us now. I'll close this and let's go quickly and create our packages. In IT world, always remember your structure is the most important thing so that it is readable to you. Never write all the code in controller or don't write everything in your service. You have to make sure you can segregate things properly. So the first thing that you need is to take a request from the front end. So there will always be a front end for you. The front end interaction with your application will be through controller. So you will have a controller package. Then you will have a service package. Now I'm going to directly use a service IMPL. That is not what you are going to do. You're going to create a service interface and then you're going to implement that interface in your IMPL. That is by using the factory pattern. Next, we need a repository where all my repositories will lie. Next, I need to persist. So I need to persist entities. So entity package, and the one which is not an entity, which is not going to be saved in a database but is capable enough to make your data transfer from one place to another, that is DTOs for you. DTOs are very important in a particular project. If you are not using DTOs, then you are using the wrong practices of using the Spring Boot in your application. Always use DTOs to take the data from the front end. So I can give you an example. If you have a front end, okay, now that has some form and some fields. Now it has 10 fields. That all 10 fields are not required to be added to the database. That is to an entity. That is why your DTO should be separate from your entity, because there might be some things which are present in your entities which is not in DTO, and vice versa, which is present in your DTO, not present in your entity. I'll give an example in few seconds. Now our packages are ready. Now I'll quickly create an entity for you. So I'm going to take an example of a microservice that is a resource management application that we are going to use. So if in case you do not have any project, a good Spring Boot project, and you guys are working in a monolithic applications with the legacy, the one I told you, the Spring ones, then what you have to do is you can use my project and I'll tell you how you can depict this to your interview. So it is win-win for us, right? So what you can see is you have worked upon a resource management system project. There you have the resources as one microservice, project is another microservice. In this session, I'm trying to cover both, but I'm really not sure how much I can cover. But I'm going to make sure at least one you should understand. So employee microservices, what we are going to understand, okay? So I'm going to create an employee entity first. Now, here comes the beauty of Spring Boot. It gives you such annotations which directly can consider this class as the table. So now this is nothing for the Spring right now. But with two annotations, I can make sure that this employee class becomes an entity and as a table in your database. So the first thing is to make @entity annotation, and secondly @table. Now this table also gives you a flexibility to name it. So I name it as EMP. Explicitly you have to tell what attribute are you setting on your table. So I want to set that my employee, whole EMPLOYEE, should not become a table name. I just want EMP as the short and simple my table name. Now for this employee entity, I need some attributes, right? So I need private int ID. Next I need the name of an employee to be added. So it will be of type string. Next, I need his age because I'll be using that in my validation. Next, I need email address, which also I'm going to use in my validation. Next, I need say project. Okay, so currently we are not going to use it, but when I'm going to use the microservice part, I will be needing it. So what I'm going to do is I'm going to pass the project ID here, and that is going to be mapped to all the structure of project details in the project microservice. So you can leave it as of now, but we are going to use it in future. And the most important part comes here. This is the creation date. Okay. Now what happens is, I want that when my employee is created in the database, I want to know the date. So when that employee is actually entering into the organization is this particular date. Now when you are going to hit with a front end with a particular request that add this employee to the database, you will not get this creation date in your DTO. So this is not going to be present in your DTO, but it is going to be present in your database, which we are going to add into the system before saving this employee to the database in the service layer. Too much not understandable? Just don't worry, I'll show that to you. Now I'm very lazy to add the getters and setters, so I'm going to use Lombok. Next, I'm going to use no arth constructor and all arth constructor. Thanks Lombok for making my life easy and just making it 5-liner code, the entity. Else, you would have written 100 lines of code just for getters and setters, which I do not appreciate. Next, if the entity is ready, with this in place, when I go to my database, if I run this application, this table should not be empty and should have been an EMP table created. By the time I'll also create the DTO for you, and I'll name it as employee DTO. This DTO is not going to have the entity and table name, but no getters and setters, I'm a lazy one. And also it is not going to have the creation date. Why? Because when you are getting anything from the front end, you will not know at what time the employee is getting added to the database. Just before adding an employee to the database, you have to save it. So that is why we have to have the creation date in the entity and not in DTO. Vice versa also, they can be multiple fields that you are getting from the front end, and you can use those fields in your service layer to validate, but not to save in the database. So it's vice versa. Many things can be in the DTO and not in entity. Many things can be in entity, not in DTO. If that much is done, let me go ahead and create the controller. So I'll have the controller, employee controller. This controller is going to handle all your request from front end. It has to be REST controller. Why? Because @controller and @request body, it has to be, response body has to be used, if not the REST controller. And I want to return everything in JSON format because I'm going to use my Postman to hit it, and the application is going to use the response from any of the methods of the controller. That is why @REST controller, which is a combination of @controller and @response body. Remember that. This is one of the important interview question. Next is the request mapping. This is the base URL. So my base URL can be like employee, and I'm going to perform actions on employee. I don't have anything in my database right now. So I need a post mapping to add something to my database. So add employee, and this is going to be a public response entity. Whenever you want to send a response back, I always prefer use response entity, and it is going to be of type employee, add employee, and it is going to have a request body, because I cannot send whole employee object DTO in a URL. I cannot do that. So I need a request body here, and this request body will be of type employee DTO. Okay, so in our controller, what we need to do is we need to have a service which is going to save the data, right? So, and we need to have a repository. So first let's create an interface named as employee repository. It is going to be an interface. This interface is going to be a type @repository, and it has to extend, because it is an interface, it has to extend the JPA repository. The type that I am going to save in the database is employee, and its ID is of type integer. Now the repository is ready, and I want to auto-wire this in the service layer. I am going to take a shortcut. I'm going to create the employee service IAM field directly. You don't do that. You first create employee service interface, give all the methods there, implement it in your IMPL. I'm going to directly do that. In the employee service, I'm going to auto wire and I'm going to use employee repository. Now to make it auto wired, what Spring Boot do? Spring Boot is nothing internally but a Spring. Now Spring has to inject a dependency in order to call the repository. This repository has to be at the rate repository or anything, which makes it a bean. Until unless this is not a bean, you will not be able to auto wire it. So remember, the flow goes controller auto wires service, service auto wires repository. Repository is going to interact with your database, gets the data from the database, give it to your service IMPL and later gives it to your controller, which gives it to your front end. So this is the basic flow. Again, front end to controller, controller to service, service to repository and back to the front. Now this service IMPL is going to have a method. So employee, save employee. And what you are going to get is employee DTO and your task is to convert it to entity. So code to convert DTO to entity and return that. So employee repo dot save the employee DTO. So currently you don't have the entity, so you are not able to save it. And return, currently I'm going to say null, but you are going to return this save. So this is the structure for the service IMPL and the controller will auto wire the service for you. So employee service. Now this is why I say here you could have used employee service interface. I have to use IMPL because I'm lazy enough to create it. Don't do that. Now employee service dot save the employee DTO. So we're sending this employee DTO and you're going to return it. But the return is a response entity. So the return will contain a new response entity, right? So I'll say return new response entity and there will be two values going. First, the employee DTO or the employee entity that is saved, and secondly, the HTTP status. The status should be created. Why? Because you have created an employee in database. So remember, these HTTP statuses are also important. This will give you 201 when it is created. So this is the controller ready. Now the service IMPL to convert it to DTO. Now let me give you one basic example. Let me just take an employee initially, not the DTO. I'll show that how I can do that and then we can convert the DTO to entity and so on. Just to check whether this much is running or not, because if you write all the code and then you try to find an issue, that will be a problem for us, right? So let's quickly try if this is running or not. Okay, so our flow goes, we are going to add an employee. We are going to pass from the request body. Then you are going to go to the service IMPL and save it. While saving, we are going to call the repository. Seems good to me. If some issue comes, we will debug and we will fix it. Now here I'm going to add a request and we need a post request. We need http://localhost 8081 because the application property says it's 8081 and my controller's base is employee, which is true, and /add is perfect. In the body, I need to create a JSON and JSON is going to have some fields from employee DTO. For a change, this time it's employee. Okay, one thing we forgot. The important thing we forgot. I want this to be auto-generated. The ID should be auto-generated. To make it auto-generated, we have again a beauty of annotations available. So annotations we are going to use as ID, which makes this a unique identifier for the table. Secondly, we need generated value. And this generated value is going to have a strategy. This strategy is going to be a generation type dot auto. Now what it says is that Hibernate is going to do one task for me. I am not going to pass you ID. You are going to generate it for me. And for that you have to create a table. When I go to the database, I'll show you two tables. But there's just one entity. Why two tables? One table is created by Hibernate to do my task. To create an ID and keep the number. Like if I have added 1, then 1 will be the value into it. If I've added 2 employees, 2 will be the value into it. So with +1, the next will be added to the database, and I don't have to pass an ID here at all. But what I need to pass is a name. I'll name it as code right now. Then I'll be passing age, then email address. I am putting it properly because I'm going to use validator and it's going to throw an exception on my face. So let's just put it a better one here only. And the project ID here. Now the creation date will be a problem, right? So currently, let me comment it up. I'm not going to pass a creation date because my DTO is not going to have the creation date. So I'm going to comment it. Great. So my body is ready and my employee table with the data is also ready. Now if I try to run it, I might face some issue. Fingers crossed, it started. Great. Okay, so this is started. Now let's quickly run and try to add. Are we in debug mode? How to check that? In debug, yes, we are in debug mode. And do we have the... Okay, so we have everything in place. Let's try to hit it and see if debugger comes. Great. Is my employee fetched? Yes, I have everything. Remember, this ID is 0, but it is not going to be 0 when the table is created. One more important thing I want to see is my table created here? I'm going to refresh and yes, I have an employee table created here. Perfectly fine with the 0 data here, but it is going to have something. One thing also to note here is that here there is no last creation date. Why? Because we have commented it right now. So there is no creation date here right now. It's just the ID, name, age, email address, project ID, and the creation date. So till now, everything is great. And we have our debugger here. Great. In the service IMPL, I don't have the debugger. So let's put a debugger here and let's save this employee in the database and see. Does it go? Now this is the beauty of the property that I've told you. If you have not done show SQL true, you will not be able to see how many queries have been added in the database for you. So these are the 3 queries that is fired on your database. First is to select the next value from Hibernate sequence. Now as suggested, I've told you that we will have 2 tables, not just one. So this is the Hibernate next value. So next time whenever I'm going to add anything, it is going to be started with the second ID 2 because 1 is going to be already used here. Now this is added successfully. And if I refresh, the 1 is added successfully. So that is why the Hibernate sequence is 2 because it is added successfully. 1 code decode with everything possibly we have. Great. So our first part is done. CRUD is perfectly running fine. CRUD, not just CRUD, just one part of the CRUD is running perfectly fine. So in this DTO, I am going to now again use the creation. Now, if I just terminate this and if I run this again, what should happen is I don't have the creation date here. With this property of update, I should have the extra column added here without dropping my first row. And the value will be null by default because date is the class and the class default value in Java is null. That is why you will get the default value here. If it would have been int, you would have get 0 or something. Great. If that much is clear, in the employee, we have the creation date available. In the DTO, we have everything available. In the controller, I'm going to have the DTO now. And I'm going to pass this DTO now. I'm going to pass this DTO. In the save, it shows me an exception because this is an employee. I want employee DTO. With this, I am going to need a converter to convert this DTO to an entity. Now, this is the problem with us, right? What you would have done, what I would have done if I would have been in an old basic Spring or Spring Boot project, I would have created a mapper. Here, I would have created a new package named as .mapper. And I would have done employee.getName, employee.DTO.setName. Sorry, employee.DTO.getName, employee.setName, employee.getID, employee.setID. I don't want to do that. I'm such a lazy person for that. So what I'll do is I'll add something to my form. And that's the best part of this Spring Boot. What am I going to add to my form? Just a second. In this dependency, I'm going to add one more dependency. That is Mapstructs. I'm not going to take your time. Do it everything manually. I'm going to take it from here. This is all available to you with the GitHub link. You can see that there also. So I'm going to use Mapstruct. It is given by ORG. This is Mapstruct is the one who is going to help me do that. But this is not sufficient. What I am thinking of is that at the end, in this target folder, this is the target folder, right? In the annotations, I should have my IMPL for the annotations created, which will have getter setter. I don't have to write it. So for that, to create at the build during the runtime, I need a plugin. Now you have a plugin section here, right? So you have plugins, that is a parent. Now this is the plugin which is the child of it, and this is the plugin that I am going to use for my annotations. Everything in place. I am not going to use version because it is going to override it. So I have my Mapstructs in place. I have my plugin in place, and this processor is going to create an IMPL at runtime in the target folder for me. So if I try to find say populator, we don't have any populator right now, right? So let's create a populator first, and then the populator IMPL will be created in the target folder. For this, I need to run it, and currently I'll just return null, else the build won't run for me. Is there any issue in this project? No, I don't think so. And now let's quickly run a Maven install. Even Maven update will work for you. Just for removing all the target folder, I'm running the Maven install. Once the build is successful, so you can see we are downloading. Oh, okay. I think I missed that thing for you. So we are downloading this Mapstruct processor for you. So that's why I always prefer Mapstruct, because it's just a simple dependency that you can add. Just a plugin that you add in your pom.xml and you are good to go. Our build is success. Great. With just this, what I can do is I can create a populator. So in this mapper, I'll create a new interface. I'll name it as employee populator. This employee populator is a mapper. This annotation you will not get until you don't add Mapstruct to your pom.xml. Now with that mapper, I want to use this populator. Now this is an interface. I cannot create an object of it. So what I need is I need to create an instance of it. So employee populator, I'll say instance, because this is going to be a final object. Anything in the interface is final. So I need to instantiate this. So mappers, this is from the factory. So they have also used factory design pattern. So we should also use it in our project. But that's the better way how to do that. Now get mapper, and I'm going to use employee populator.class. Now our instance is ready, and now since it is an interface, we cannot create an object, but you can use this instance now. We are good to go. Now I just need a method, one single line, and you are good to go to convert your entity to DTO and DTO to entity. I am here converting an DTO to entity. So I need an employee in return, and my method name will be populate employee, because that's what I'm going to create. And I'm going to pass you employee DTO. When I'm passing you employee DTO, I want employee in return. Great. How to use it now? To use this particular populator, I need to use an instance of it. So in the service IMPL, here I'm going to use the code to do that. So what I'm expecting in return, I'm expecting an employee object which I'm able to save in the database. To make it return, I need an employee populator. This is an interface. I cannot create an object of it. So I have the instance of it, which is a final instance that is already created. And with that instance, I can call a method with the employee DTO. Now at this point of time, what all I pass in this DTO should be received as an entity to me, and I should be able to save that employee in my database. So this is the way to use the populator. One single line and you're good to go. Else you would have created mappers, getters, setters. I don't want to do that. So this is a smart work. Now I think we are good. Let's quickly see the flow. We are going to save a DTO. DTO is going to call the service IMPL. Service IMPL is going to call the instance. We're going to create an entity instance. Entity instance is going to save using this repository. I think we are good. Let's quickly go and debug this and let's see if this is working fine for us. And also meanwhile, I want that my target annotations should have populator. So I have employee populator. So I just have employee populator.java and that is just an interface. So I'll do Control Shift T for employee populator. Oh my god. So it is not created in the target class. Let's stop it first. Let's again run the Maven build. And by the time I'll go to the target folder. And in the target folder, I would be needing classes. No, this will be going to have the classes. I need an annotation. So I need to build it. So I'll run as Maven update. Great. @mapper is also there. And the instance is also created. And we don't need any mapping and it is good to go. With this, if I try, I should have employee. Great. So can you see employee populator here? That is at target generated source annotation. So target generated source annotations. Here, can you see this particular IMPL created? I can go here and can show you that in the mapper, the IMPL is created. And this is in target folder. That means I have not created it. Who has created this? Spring Boot has created this for me. Okay, so this is generated by the Spring Boot for us, the employee IMPL. It checks if it is null, it returns. And this is something, can you see? You would have seen this code in your manual mapper. So this is the task done by Spring Boot for you. You don't have to write it. Now, can you see one thing? Can you see this ID also getting populated? I don't want this ID to be populated. Why? Because I have made my entity. If you can see here, this entity is auto-generated. I don't want to send anything from here. So if I send 20 from here, it will give me an exception. I'll show you that. So let me quickly run this as everything is ready for us. Let's see if this is running. And our populator is also in place. Great. But this has ID, which is a problem for me. So if I say that I pass ID as 20, won't we be in a problem? We will face an issue. I'll show that issue to you. If I send it, it will give me an exception. Oh, just a second. Please don't tell me it is added. In the employee table, if I try to refresh, oh, it has overridden it. So this is so bad. It has overridden. I have passed 20. That too, it has overridden and added 2, which is also the worst thing to do. If I am passing an ID, you should not add whatever the Hibernate is expecting. Rather, what I need now is that don't please add anything to the mapper. So in this populator, I don't want to please set the ID. So what you can do is, in this populator, you can ignore ID and by the end, you will have this line removed. So here, what I'll do is, I'll use mapping. And this mapping will be from org Mapstruct. Now my target is employee. This employee entity, I do not want ID to be added. So I'll ignore ID. How will I ignore ID? I'll add ID field, comma, ignore equals to true. This is a Boolean value. And when I do that, the ID is removed from here. Can you see? This is as quick as that. And that is why I love Spring Boot for this. This, as soon as I've added the ID, it has removed the ID from here. But now can you see one warning? Can you see this warning as unmapped target property creation date? So here we have creation date that is not coming from employee DTO, but it is in this entity. So if you can see here, this is the creation date. To remove this error, let's just go and add that also, because since you're not going to get it from DTO, why are you adding it to your entity? So let's quickly remove the creation date also from here. Oops, I'm sorry. Great. Now we can come back here and our populator is ready. And in this populator, ID is removed and even that is also removed. Because employee DTO does not have creation date, how can it set from getting the creation date? That is why it has not added the line here, but it was giving a warning in populator. Here in the populator, it was giving a warning. Now this warning is gone. Now we are good to go. Now let's close this. I should have actually done the auto build for you, but you won't be able to see the differences. That is why I have not added to the form.xml. I'm going to save everything, and now even I don't need to pass this. Even if I pass this, it will be ignored. It was anyways ignored, but it was giving an issue. So the creation date is also working fine, and I remove this for better visibility to us. And now when I hit this, it is going to save the database and it is going to be inserted. If I open, it should have 3 layers now. Great. Now the creation date is null. So this is what I was telling you. When the first time creation date is null, because we have not added it at all. The second time it is null because the default one is null and we have forgot to add the creation date to our service IMPL. So what you have to do is, just before saving it here, in the employee dot set the creation date. Just before saving it, can you just do new date? If you do that, the current date is going to be saved in the database. I'm sorry, I have to run it again. Now if I try to hit it, the database has been added with the new data, and if I refresh, see, I have the latest date, that is 10 o'clock, the 4 p.m. That is the exact time, that is for the today. So this is how you should always add a creation date before adding any entity to the database, to make sure you know when the entity is added to the system. And that is how you can make the system resilient to changes.
It was all about implementing Mapstruct from scratch in Spring Boot project. In the next video, we will be seeing how to implement the custom annotations and custom validators in Spring Boot project in continuation of the same project. If you want me to create a video on that, just let me know in the comment section. We'll upload one more video on continuation of this video itself. Thank you.